Hey math kids, we're going to just continue with double angle identities. So we have sine alpha is equal to 5/13, and we're told that it's in the second quadrant. This is pi halves, and this is pi. Okay, we need to get our cosine value first before we answer the questions that they want. So they want us to find sine of 2 alpha and cosine of 2 alpha, but we need a cosine value first. So we're going to use the Pythagorean identity, which is this, and then we're going to plug this in for the sine right here. So we get 5/13 squared plus cosine squared. I'll change it to an alpha because that's what we're doing. Okay, we square the top and the bottom. We get 25 over 169. And then we want to solve for cosine. So we're going to move this onto this side. Then I'm going to think of the 1 as 169 over 169. And if we do that, we end up with 144 over 169. Okay, now we're going to square root both sides, and we get cosine of alpha is equal to plus or minus 12 over 13. But since we're in the second quadrant and cosine is an x value, the x values are negative, so we just have negative 12 over 13. Okay, now we have our sine and our cosine, and so we can actually answer the questions that they asked. So let me just make some room, because we don't need that anymore. Okay, so if we have sine of 2 alpha, and we use our double angle identity, that's the same thing as saying this. Then we just plug in our values. So we have 2 5/13 times negative 12/13. And if we just simplify this, we're going to get the bottom is 169, top is negative 60 times 2, negative 120, and that's it. Alright, now we're going to find cosine. Oh, actually it wasn't cosine, it was tangent. Sorry, I wrote that down wrong. So now we want to find tangent alpha. Actually, this might take some room, so let's get rid of this. Okay, so this was supposed to be tangent of 2 alpha, 2 alpha. So tangent of 2 alpha, if we use the identity, we get this. Now, I think it's helpful if we find out the value of tangent alpha first before we try to plug it in. And so tangent alpha is equal to sine alpha over cosine alpha. So we have our sine, which is 5/13. We have our cosine, which is negative 12/13. Since those have the same denominator, those cancel. And so tangent alpha is equal to negative 5/12. Alright, now we can plug that in up here. So we're going to get 2 times negative 5/12, and then 1 minus negative 5/12 squared. And now it just comes down to simplifying. I don't really need that anymore either. This. Okay. So if we multiply this out, we think of it as 2 over 1. We end up with negative 10 over 12 on the top of our fraction. This is going to be 1 minus, if we square the top, we get 25. Square the bottom, we get 144. Now, if we think of the 1 as 144 over 144, let's see, 144 minus 25, that would be 39, and then 119. Okay, so the bottom of the fraction becomes that. And we reinterpret that. Which we flip the second one, make it multiplication. Alright, this cancels this but leaves a 12 on top. And then 12 times negative 10, it's going to be negative 120 over 119. And that's our final answer. Okay, now we have alpha, and it's defined as being acute. And now we have cosine of 2 alpha is equal to 3/4. And we want to find the exact value of cosine alpha and sine alpha. Okay, now cosine has 3 different double angle formulas, like cosine of 2 alpha. And so we just need to pick the one that we think is most useful. So we want to pick one that only has cosines when we're dealing with this one. And so the one, because there's one that has a cosine and a sine, there's one that has only a sine, and one that has only a cosine. So we're going to use the one that looks like this. Because it's the one that has only a cosine in it. Okay, now what we can do is we can plug in, replace that with this. So we get 3/4 equals 2 cosine squared theta minus 1. And we just go through some algebra, add 1, add 1. I'm going to think of the 1 as 4 over 4. So that leaves us with 7/4 is equal to 2 cosine squared. This should be an alpha, I apologize. Okay, now we can divide by 2, which is the same as multiplying by 1/2. And so we end up with 7 over 8 is equal to cosine squared alpha. And then we just square root both sides. And so we end up with plus or minus square root of 7/8. Now, because it's acute, that means it's in the first quadrant. And the first quadrant only has positive cosine values because cosine is x, and these are positive values. So our final answer is just the positive one, which is the square root of 7/8. Okay. Now we need to find the sine. So we're going to go through a really similar process. But we're going to use a different version of the double angle identity for cosine 2 alpha. So we want to use the one that has only sines in it. And so that's 1 minus 2 sine squared theta. And we plug in the value 3/4 for this. Alright, we subtract 1. We think of the 1 as 4 over 4. So that's negative 1/4. We divide by negative 2, which is the same as multiplying by a negative 1/2. Those cancel. These negatives will cancel, and we have 1 over 8, which is equal to sine theta. That's really supposed to be an alpha on all of these. Okay, square root both sides. we end up with plus or minus square root of 1 over 8 is equal to sine alpha. Once again, we're in the first quadrant. First quadrant right here has positive y values. Sine is a y value. And so square root of 1/8 would be our final answer. Okay, we have a couple more. Okay, so we have, this one just wants us to simplify. Okay. Now, what we're looking for is something that looks like one of our double angle identities. So we have a double angle identity that looks like this. And this almost looks like that. It's just that 2 and that 3 are different. So what we're going to do, we're going to kind of separate it. And so we're going to ignore the 3 just for a second. Now, if we wanted to make this thing on the inside the same as this, we would just multiply by a 2. Now, because there's not an equal sign, we can't multiply on both sides of the equal sign. So the way that we get around this is we multiply by 2, but we also divide by 2. And that might seem a little silly, but what that allows us to do, it allows us to replace all of this with this. And so we still have this 3 halves on the outside, and then we have sine of 2 theta, and that's our answer. All right, now we have just one more, and it's going to be kind of similar. So we have 4 cosine squared of 2b. Once again, there's implied parentheses there, minus 2. Okay, now what we need to make this kind of look like something that we have. And since it has the cosine squared, we're going to look at cosine 2 theta is equal to 2 cosine squared theta minus 1. So it looks like we can almost get this looking a certain way, because it almost looks like this. And so if we factor out, let's try just factoring out a 2. And so that's 2 cosine squared of 2b minus 1. And it's looking pretty close. The only difference is that the 2b, we're going to consider that our theta. But we could just, if we call that 2b, we could call that 2b. And so over here, it'd be cosine of 4b is going to be the only difference. So all of this can be replaced by that. And 2 cosine of 4b, and that's where we're going to end. If you have additional questions, please come to Math Lab. Until then, calculator.